week we were working on activity A of Thursday, and it's practice solving integrals of hyperbolic functions.
I'm Matt.
I'm Joachim as well here. Oh, here it is. I actually pulled up the derivative one. Okay.
I guess I don't really understand these too much with what to do with integrals on these. So
If you have that paper, it is just a conversion. You're just rewriting it to what they want to see.
What they have it.
I mean, you're finding h's cosine of h.
Okay. So it's not too bad, I guess.
No, it's not bad.
Yeah.
So maybe I'm wrong on this first one, but so let's see. Hold on.
So
there you are. Okay. So
so it'll be negative. Because it goes from sine to cosine.
No, it actually doesn't do that conversion in this one.
Oh, really?
Yeah. So what you can start by doing is put 1 minus 2x as u.
Okay.
So then we have sine hyperbolic whatever. How do you pronounce that?
That's right. Yeah, you got it. Hyperbolic.
Hyperbolic sine. Okay. And then you take the derivative of u. Which is negative 2x. And then move over, so it's like du equals negative 2x dx. And then, wait a moment. No, it's negative 2, not negative 2x dx, sorry. And then you divide by negative 2. So you have du divided by negative 2 equals dx. So in front of the integral sign, you get negative a half. And then sine hyperbolic u du. And now you can just make it to whatever that is. So like that gives you negative 1/2 cosine hyperbolic or whatever, and then times the derivative of u, which is 1. And then you substitute back u into it. So you end up with negative a half cos h 1 minus 2x plus 3. Did you get that?
Yeah, that's what I got.
Yeah, that's what I had.
Huh?
Yeah. Yes.
Okay. Cool. What about you, Gage? You good?
Yeah, that's what I got too. I guess I just worked through it as you were talking. So.
Okay.
Hey guys, sorry, I have to step away. 2 of them just threw up on my wife. I've got to go hold one of them. So I'll join back in if I can, but sorry, I've got to take off.
Good luck.
Okay.
Sorry.
You're good.
Thanks.
Okay, so for the next one, would you just have your u as the bottom half is the denominator?
I would just say it's root x.
X. Okay.
So if you think about it, when you take the derivative of root x, you get 1 over 2 root x, right? So you want to do the license, the half in front of the integral sign, so you have sine hyperbolic u over. Okay, sorry, that got confusing. So like if you set u equals root x, du over dx is 1 over 2 root x, right?
Yes.
And then you multiply by 2, so 2 du equals 1 over root x. And that's what you have there, problem, so that you can make that a du.
Okay.
So that gives you 2 integral cosine u du. Just use the formula.
You'd substitute that back in. So then that would give you 2 sine hyperbolic of cosine h of x.
No, just root x.
Just root x?
So 2 sine h root x plus c.
Okay. That makes sense now.
Okay.
The next one.
License problem.
Yeah, I guess.
So here, u equal to cosine hyperbolic x minus 1. Of that, we get sine h x minus 1.
Yes.
So that means that we have that du equals sine h x minus 1 dx. And so we have integral of u squared du. And we take that integral, we get u to the third power divided by 3 plus c. And then substitute that back in, we get cosine hyperbolic to the third power x minus 1 divided by 3 plus c.
Okay, that's starting to make a little bit more sense.
Yeah.
So I really struggle with the license stuff. Like that's still it's hard.
Say that again.
I struggle with the license. I struggle with the license stuff. That just is hard for me to understand.
Oh, okay.
So that's where I get lost on that stuff.
A derivative of something that equals what you have already. So that you can, yeah. It's gonna be hard to, I mean, yeah, I don't know.
Okay. So for the next one, Um, man. So I guess would you set your cosine? So would you need to put u in this one? So would that be your just your x, or would it be your sine hyperbolic of x?
The whole thing.
Okay.
Because what happens if you take the derivative?
But you just cut out. What'd you say?
What happens if you take the derivative of that?
Of the whole thing?
No, of the u, of sine A.
It would just be 1. Oh, I guess.
It becomes.
It changed the cosine. Yeah, it changes to cosine. So then that would just be 1, or I guess it'd just be x.
Wait, say that again?
Oh, you would, if you took the derivative,
Mm-hmm.
the du of u, so on the bottom, that would change the cosine hyperbolic of x.
Yeah, but you said du over dx equals cosine hx, and then you move over dx.
Okay.
Because then you can match what you have. Because over there on the top, you have cosine dx.
Okay.
So what's left?
Your dx.
No, your du over
Yeah,
sine hx.
Yeah.
Which is 1 over u du. So what did you get?
At the end, when I substitute it in, I get sine h of x plus c.
Wait, say that. How you cut out?
I got sine hyperbolic of x plus c. C.
Okay, but it's the ln of that.
Oh, yeah, that's right.
With the absolute value of sine
Okay.
For you.
Yeah, I went over that. Okay.
Cool.
So then we have x cosecant hyperbolic squared of x squared over 2 dx
Formula secant hyperbolic squared. It becomes like negative cot h.
Okay.
So if we equals 2x divided by 2, no, x squared divided by 2, sorry. Our du equals x dx. And then we can take out the x and dx for the du. So that gives us the integral of cosecant hyperbolic squared, or u squared. Or, no, sorry, cosecant hyperbolic squared u.
Squared u, yeah.
And then that gives us negative cot hyperbolic u plus c, and then substitute back x squared divided by 2.
Okay, that one was a little easier.
Yeah.
Now the last one. I I guess you could use yeah, so we have that formula for that. So it would be, so you'd set your, so it'd be du equals x squared dx, correct?
You want to set the u first.
Or okay, your u is going to be the top part, your numerator.
It will be 1 over x.
Or 1 over x. Okay.
And if you take the derivative of that,
the derivative of just the 1 over x?
yeah.
Okay. So then you have your du equals
It's negative 1 over x squared.
okay. So then the top converts, then your top converts to CSCH.
Yeah, but before you do that, you got to take out the
Yeah.
negative sign. Did you do that?
Take out the what?
The negative sign. 'Cause you have 1 over x squared, because you don't have a negative sign in your license here.
Oh, yeah.
So
Yeah.
put that one in front of the integral. So
The
you
negative integral of CSCH of u,
Mhm.
and then cotangent of u, or cotangent hyperbolic of u. So then that ends up as CSC of h, and then 1 over x plus c.
Yeah. Yeah. So in the end there you had the du as well.
The du up at the top.
In the one before that, so cosecant.
Yes, yeah.
Yeah, right. Okay, good. You got that. Sweet.
Okay.
Yeah, that's right.
I guess I really struggle with integrals a lot. Like that's been my hardest thing that I struggle with. I guess it just calculus has been hard because I've never really taken it before, so it's all new.
I understand. I have not taken the trig part. Like
Okay.
okay, I'll stop recording now.